This is the energy meter. Is a Genus company, which have been installed for this feeder. Is a 132 kV feeder of this substation. So this meter has been recently installed, and in this video we will be just checking if the connection has been done correctly or not. I mean, for that we will have to check the parameters, and the parameters that we usually check is number one is your current, because current here also will be showing our y-phase secondary current, and then your power also it will show here, which is actually tap from the city secondary. So we will be just checking these two parameters, and multiply with the your multiplying factor and your CT ratio. I mean, having these two known quantities with you, your CT ratio and your multiplying factor, you can check whether the connection of this energy meter is a three-phase energy meter is okay or not. This is what we normally do. So for that, let's go first to current. We'll just check the current RY phase, but then I think we'll just take one current only, maybe R or Y or B phase, and if it's okay, then the rest of the currents also will be okay. Let's go back to current. We'll just keep pressing this back push button. Will keep pressing till you get the current uh, in ampere. Yes, so this is your R phase current 0.229, and your Y phase is 0.239, and your B phase secondary current is 0.236. For example, if I am taking this B phase current, which is 0.241, 0.241, here let me write here 0.241. This is your R phase current. R phase current secondary, it is how much it is right now, 0.2. Let me take 0.240, 0.240. Now if I multiply this current with your CT ratio, which is nothing but 400 is your CT ratio, then how much you are getting? 0.240 into 400, so approximately 96 ampere is your B phase current. You're getting 96 ampere is your I1 or your primary current. And let's go to the relay and check if the relay reads the primary current of B phase as roughly 96 or not. If it reads 96, that means it is okay. So we'll just go to the REC 670. This is your ABB relay. It is actually your BCU, Bay Controller Unit. It records the values, and we'll just go to the measurement, and then see, you go to analog primary values, and then go back to TRM 40, and we'll just see the I was just checking the B phase. That means CH3 channel number 3, you are getting 91, 92. So roughly it is equal to your calculated value of 96, which I've just got. So that means the correction is okay, and same thing can be done for other phases also. And just I was just going to the measurement. If you want to see this quickly, this you go to single line diagram, and then again go forward. This is what you're getting. The value of B phase current is 90.55, which is very near to your the calculated value of 96, because actually it has got changed. Otherwise it would have been 96 at the time, and I was just watching the values. So this is how you check the current. You take the secondary current and multiply with your CT ratio, you get your primary current, which is recorded in this relay. That is number one. Okay, and number two is your power. I said number one is your current, and number two is power P. Number two is your power P. Now this power P, which is your energy meter records, if you multiply it with your multiplying factor, in this case your multiplying factor is nothing but your CT ratio into PT ratio. In this case it is 0.48. So It is whatever value that you will be getting here. P from the energy meter, you multiply with your multiplying factor, which in our case is nothing but 0.48. So let's go to the meter. We'll just see the how much is the power. We'll keep on pressing the back push button till you get the power. uh, Ampere it's showing here the voltage. This is your secondary voltage, and when you multiply it uh, with your factor 1.73, you are getting your face to face, and then multiply with the factor around 1.2 something, you will get your primary voltage. We'll just go back because our aim is to check the power. This is a power factor, volt ampere. This is your watt. All right, this is 51.30. 51.30. This is right now, say I'm taking it as a 50 watt. So 50 watt 50 watt into 0.48, how much you're getting? It is almost like roughly 25. 50 into 0.48, so roughly 24 megawatt is the present power transfer. Roughly 24 megawatt. Let us just check from the relay how much is it. You can see here it is 25. This is a mistake in this. Actually, this is not 250, but it is 25 megawatt. So the connection of the meter is okay. So what we have just done is we have first of all check two parameters. First is your current. You just check the secondary current, and when you get the secondary current, you multiply the secondary current with your CT ratio. You will get your primary current I1, whatever phase. Now I'm just taking a single phase. And second, what you have to do, you just take the power of your which is recorded in your energy meter, and you multiply it with your multiplying factor, which is in our case is nothing but 0.48. You will get your power in the primary, that is your real power transfer in the feeder. So this is how you actually check. It's very simple. And for other feeders also, to 220 kV feeders or 400 kV feeders also, I mean the same thing can be done in all the substations. And this is how we check the connection of the energy meter. I mean this is a quick check in fact, and the details on how connection is done is basically it's done with the help of a circuit diagram only just in front of you. But if in case the meter actually give you the correct reading or not, that is what you have to check. So this is how, and these are the relays, BCU, and this is your overcurrent relays REL670, and the other one is your distant relay. This is how we do in a substation. And just recently also we have installed this line differential relays, just new. I mean we are adding protection to the system. This is so. Thank you. This much only.